This video is another video for determining whether the given differential equation is exact or not, because if it is an exact differential equation, there is a specific method in solving such. Here, we're going to focus only on, as mentioned, determining whether this equation is exact or not. And if it is, then we will have a separate video for the solution. In order for us to determine whether this is an exact differential equation or not, this form should be in this form here, m of xy dx, that's dx, plus n of xy dy equal to 0. Once we can establish that, we can now say a certain function of m of xy and n of xy. We will be needing both of this because in order for us to structure that our equation is an exact differential equation, we need to show that the partial derivative of m with respect to a certain variable here, y, is equal to the partial derivative of n with respect to x. This should be satisfied in order for us to say that the given equation is an exact differential equation. But first, let's determine the m and n here. Our m would be this paired with d of x as given in the form. So our m is 2x minus 1. Okay? Similarly, our n of xy is actually 3y plus 7. So now that we have established this, let's try to show the partial derivative of m with respect to y, and later on the partial derivative of n with respect to x. Take note that it's considered to be partial derivative because we are only going to take the derivative with respect to a certain variable. In this case for m, that's y. Please don't interchange these two because it will be a mistake later in your process. So with this, our partial derivative is taking consideration the variable x as part of the constant. Since our given function for m of xy is 2x minus 1, and both terms did not contain variable y, we are going to treat both terms as constant. Even if this has x, it will be considered as a constant because we're taking the partial derivative of m with respect to y. If this is now a constant, that would mean its first derivative is 0. And of course, the first derivative of a constant minus 1 is also 0, giving us a result of just simply 0. Please don't be confused with this. We are taking the first partial derivative of m with respect to y. And since x is what is given, we'll be treating that as constant. Similarly, the partial derivative of n with respect to x, since our given here is 3y plus 7, there's no variable x in both of the terms. That would mean we'll be treating them again as constants. This means that this is also 0 plus 0, and the first partial derivative of n with respect to x is also 0. With this, we have established that the partial derivative of m with respect to y is just equal to the partial derivative of n with respect to x, and they are both equal to 0. Okay? Please don't be confused with that. Hence, our given equation is an exact differential equation, and we are going to use a specific method if we are tasked to solve for this given equation. Thank you very much for watching.